Hello everyone and welcome to this video where we will be talking about generators. In the previous video we talked about motors, and in this video we will be talking about generators. So generators are simply devices that convert kinetic energy into electrical energy by using the idea of induction. It is the opposite to the job of a motor, which converts electrical energy to kinetic energy. The idea behind this is induction. Again, we learned from Faraday's law that changing the flux will cause a current inside a wire, and that's the main idea behind how a generator works. There are two types of generators. There are the direct current generators, and the direct current generator has the exact same components of a motor, but instead of connecting a battery, we will be connecting wires to a source that will use this energy, for example, a lamp. By rotating the loop, we are using the idea of induction to create current inside this wire, and this current will be used by, for example, a simple lamp. So that's for a direct current generator. But for an alternating current generator, which is the second type of generators, an AC generator will create an alternating current. Notice that the difference between an AC and a DC generator, AC stands for alternating current and DC stands for direct current. The difference between them is the formation of the brushes and the slip rings. Look here. Here we are going to introduce something called slip rings. We introduced brushes before. Now let's look at this simulation. It will really help us understand the difference between these two types of generators. Okay, now let's look at this very nice simulation for a direct current generator. Just as we spoke before, it looks exactly like a motor where we will have two brushes and there's this small gap which is colored in black. Let's start this simulation. As we can see, there's this lever arm which is rotating this loop of wire. When this loop of wire is rotating, as you can see, the number of magnetic lines passing through the loop is changing, which is exactly changing flux. Since flux is changing, we are producing electricity. But what is the idea behind being a direct current generator? At a certain moment, the brushes will be touching a gap right here. At this moment, we are not producing any electricity because electricity is not passing through the wires anymore. So this means that I am always keeping the direction of the current in the same way, which is another definition of direct current. So the current is always going in the same way. Now, we can even look at the voltmeter right here. The voltmeter is always giving a positive reading. And if we look here at this graph before, we've seen this graph before, we are using this graph to represent direct current. Now, let's change the formation of the brushes here and introduce some slip rings. Now what we are doing is that we are producing alternating current electricity. As you can see, the potential difference is negative, then it's positive, then negative, then it's positive. And we can also see that on the reading of the voltmeter here. The idea here is that every brush is connected to a slip ring and it is always connected to this loop of wire. So when the loop is rotating, it is producing electricity, but this electricity is once going in a certain way and now it's going in a different way. So when it goes back and forth, as you can see, when you look at the arrows right here, we are producing alternating current electricity. Now that is the idea behind generators, which are direct generators and alternating generators. I will be putting this link of the simulation in the description. I hope this made things more easy. You can watch the video again and again until you get the idea, and you can use the simulations yourself. They will really help understand these two important topics. This is the end of the chapter. I hope to see you in the next videos. Stay tuned.